What's going on, y'all? Welcome back. In this second video, we're going to continue our exploration for a way to think about the natural exponent base e. So this is a mathematical constant that is very famous. It is an irrational number, so it cannot be written as a fraction. In other words, it's an infinitely expanding decimal that does not repeat itself. The formal calculus-based definition of this thing is the limit as m goes to infinity of 1 plus 1 divided by m to the mth power. And in this sequence of videos, we're thinking about how this relates to the idea of compounded interest. So this actually comes up in the model for continuously compounded interest. So we're kind of exploring a model for how financial instruments work, and specifically we're talking about compounded interest. Before we go on and talk about how compounded interest work, we're going to actually explore something called simple interest. So there are some famous mathematical formulas that relate to interests and how interest works. And the first one we're going to look at has to do with how compounded interest, or excuse me, simple interest works. And I can't find at this moment my little fact sheet about interest rates. Let's see. So when we're looking at financial math formulas, there's a few different ones to look at. One of them is called simple interest, where the interest that we're paid is a flat fee every single period. It doesn't increase over time. Simple interest loans are actually really hard to find. I'm going to show you an example in this video of what a simple interest loan looks like and how it works. Most interest rates, so if you have a credit card or a student loan or a savings account, a money market account, a mortgage, most of those follow the compounding interest formula, which is the idea that your interest earns money on itself. And when we think about the number e, that actually follows compounding interest. But it's kind of useful to preempt that concept with the idea of simple interest. And that's what we're going to do in this video. We're going to explore the concept of simple interest by looking at a simple interest loan. So one thing that I try to do is actually give you concrete examples of mathematical ideas that actually show up in life. And I want to show you a loan that a family member made many years ago. It was a loan for a home improvement, and it was written through the Alameda County. You don't need to know the details of the person and all this stuff, but I wanted to actually highlight, this is a legal document that was used to write this loan. And the idea was that the amount financed was $88,000. This was to improve a home. And it was a 3% interest rate that was due. And so the finance charge every year was 3% of $88,000, which if you type 0.03 times 88,000, you would get $2,640 per year. The thing that I wanted to show you, though, was that this amount doesn't change every year. And you can actually see this in the way that this thing was written. So the value received, the undersigned hereby promises to pay the County of Alameda Community Development Agency the principal sum of $88,000 and 00 over 100. That's called the principal amount. It's the amount that the loaning agency is giving to the borrower. This is a deferred payment loan, which will accrue, so that means we don't have to pay back. We can hold the money for as long as we need. And it will accrue simple interest at a rate of 3% per year. So this is really interesting. There are not many loans like this. I actually really appreciated this particular agency. It's a community development agency for low-income folks. So, if you were to go into your bank and look at the technical writing in most loans that you would take out, you would not be offered a simple interest rate. The interest that you would, simple interest loan, the interest that you would be offered would be compounding interest, which we'll talk about in the next video. So we're going to look at what this actually means and why it's kind of special as we develop fluency. So the whole idea here, though, is that a borrower takes out an amount of money and then has to pay back that amount of money later in life, but for the cost of using that money now also has an interest charge. And the major question that we ask is, well, how is that interest charged? In this particular loan document, the interest is charged as simple interest. It's charged as a single set fee that stays the same throughout the life of the loan. So we're going to look at some mathematical terminology to describe this. So mathematicians will use P sub 0. This is called a subscript. That's the initial principal on the loan. And in a simple interest charge, we take some interest rate. In the case of this particular loan, we see that interest rate is 3%, which mathematically we could write as 0.03. And then in simple interest, what we do is we multiply that 3% by the original principal every period. So what's crazy about this is we're not charging interest on the interest. We're literally just charging a fee on the initial principal, which in this case was $88,000. So the amount that I owe at the end of 1 year will be my original $88,000 plus 3% of $88,000, which was 2,640, right? So 88 plus 2,640, that's the amount that I owe at the end of year 1. As year 1 goes and we go into year 2, we're going to take that new amount plus 3% of 88,000. We can kind of go through the calculations here. So we saw in that loan document that the amount of money that we took out at the beginning was $88,000. That's the initial principal or the amount borrowed. P sub 0 means it's when the loan starts. It's the 0th period we've accrued no interest. Remember this whole idea that we talked about, that when we're accruing interest, we often do principal times 1 plus some interest rate. So here, the amount that's due at the end of the first year is going to be the amount that we started with, the $88,000, plus 3% of the original loan amount. So 3% of $88,000. $88,000 plus 3% of $88,000, which is 2,640, is $90,640. And what's really nice about this loan is that the family member that did this actually, this is the exact amount that they owed at the end of the first year because they were not making payments. It ended up being a lien against the house. And so if the house ever gets sold or transfers ownership, this will be taken out of the sale price as a way to pay back. And the reason that this is interesting is in a simple interest loan in the next period, so at the end of the first year, this person owes $90,640. So P1, that's the amount that I owe at the end of the first year of the loan, is $90,640. But then we're going to add 3% of the original. So notice that that 3% interest charge is not charged on the new principal. It's charged on the original loan amount, the original principal. In other words, the interest fee is a flat fee leveraged every year. It's not increasing as the years go by. I'm not accruing interest on my interest. I'm literally keeping that interest rate fixed. It's a simple way to calculate interest, which is why we call it simple interest. And when I add these two together, my amount that I owe on that loan at the end of the second year of the loan is $93,280. Same thing is true for the end of the third year. So P2, the amount that I owe on the loan at the end of the second year is this. When I go to the third year, well, the third year is going to be the amount that I owed at the end of the second year plus an interest fee. And the interest fee in simple interest is not a percentage of my current balance. It's a percentage of the original loan amount. So remember in the loan document that we looked at, this was going to be 3% of the original $88,000. Notice that the interest fee stays constant throughout the entire life of the loan. So this never changes. In other words, when I go to the end of the third year and I want to know how much balance is remaining on that loan, well, it's the amount of balance at the end of the second year plus my fixed interest fee, which in this case is $95,920, right? So if I were to ask the county of Alameda in this case, at the end of the third year, how much do I owe on that loan? It's this amount. And for the family members that took this loan, if they were to sell their house, when they sold the house and the real estate profits came in, Alameda County would be first in line to receive this amount back to repay the loan that was used to increase the value of the house, right? To do the remodeling and kind of fix up. Yeah, and so this is what we call simple interest, and it's simple because the amount that's charged in the each period where the interest accrued is a fraction of the original loan amount. And we'll see that that's different from what we call compounding interest, because in compounding interest, the amount that's charged is a fraction of the last principal. So one of the things that's going to change is, instead of this being constant, the amount of interest that accrues will increase every period because of the way that compounding works. And we'll see that in the next video. So in this situation, we've looked at how simple interest worked with an actual example of a home loan written by a local county development. In the next situation, we'll take a look at a loan that more closely resembles probably the stuff that you see in your credit cards, student loans, car loans, mortgages, and most loans that are written on a day-to-day basis. Okay, so I'll see you in that next video, and we'll continue to work our way towards understanding how the natural exponent shows up in mathematical modeling. All right, I'll see you in that next video.